So what we want to look at today is we want to look at how we can use the Pythagorean theorem in a real-world context to answer some word problems. So it's going to use the skills we practiced on with the Pythagorean theorem lesson, where we learned how to use a squared plus b squared equals c squared. So let's just go ahead and write that down up here just as a reminder. A squared plus b squared equals our c squared. That's our Pythagorean theorem. But we're going to use it in the context of a word problem. So we need to visualize all of these things. So that's my first recommendation here, is that you really want to make sure you draw a picture. A picture here is going to be worth 1,000 words. We got to know what this looks like. So let's start off with this first one. It says that the hypotenuse of a right triangle. So as soon as I read that word right triangle, I'm just going to go ahead and draw one real quick. There's my right angle in the corner, so it's a right triangle. And it says the hypotenuse of that right triangle is 45. The hypotenuse is 45 centimeters. This is my hypotenuse, so I'm going to go ahead and put that 45 there. And one of its legs is 36. So it doesn't honestly matter which one it is, but one of my legs is 36. So I'm going to go ahead and call this guy 36. The question is, find the perimeter. What's interesting about that question is the perimeter is the distance all the way around, and we don't know the other side. We don't know what this side is. So before we can actually find the perimeter, we can't find the perimeter yet. We have to find that other side. So to do that, we use our Pythagorean theorem like we've been practicing. Let's go ahead and set it up. I'm going to say x squared, that's going to be my a. So this is my a. This will then be my b, and this will be my c. So x squared plus 36 squared equals 45 squared. So obviously you'd want to use a calculator if you need it, Desmos, however you need that. But 36 squared, you can go ahead and figure out what that is. That's x squared plus 36 squared is 1296, right? Equals, our 45 squared is 2025. So we've now got our equation almost there. We need to subtract this over. So if I subtract that 1296 to the other side, and when we do that, we are left with our, we're left right here. Here's our equation. X squared equals, when we subtract over the 1296, let me just type that in real quick to make sure we're good. We're left with 729. Now be careful, that's not your side because you still have to take the square root of both sides in order to figure out what that last side is. So our last side is actually 27. So the temptation here, and on any test you might take, would be to write down that x equals 27 as your answer. But it's not, because we're still trying to find the perimeter of this shape. So I'm going to go back here and write down 27, but then come back and say, okay, well, the perimeter then is all of the sides added together. 27 plus 36 plus 45. So if we add all of those together, we're left with 108. So the perimeter of this triangle is actually 108 centimeters. So if you see, it really helps to draw that picture and then be very careful to answer the question that's being asked. That's the kind of the dangers there to avoid. Let's keep going, and we're going to do another word problem here. You're going to practice these later in your lesson today, but I really want to help you with the visualization. So we have a 15-foot ladder. There are a lot of ladder questions when it comes to the Pythagorean theorem. So if you think about a ladder, the way a ladder works is it leans against a wall, right? So you got to be careful here. The wall is 13 feet. So a wall has to stand vertically. So there's our wall. Our wall is 13 feet. And we have a 15-foot ladder, and it does reach the top. So it does reach all the way up here. But a ladder always leans. It has to lean. Your ladder is always going to be your hypotenuse. Your ladder is always going to be your hypotenuse because the ladder is leaning against that vertical line, the right angle. So we don't know that bottom side. So the question is, that's what we're asking. How far from the base of the ladder is it? And again, we're going to solve using the Pythagorean theorem. We don't know what this guy is. So x squared plus 13 squared equals 15 squared. I'm going to speed this one up just a little bit. If we subtract that 13 squared to the other side, so we need to bring this guy over, subtract 13 squared, then 15 squared minus 13 squared gives me 56. Okay, and we're not quite done because it's still x squared. We need to get rid of that square root. So we take the square root to get rid of the squared, excuse me. So we take the square root of 56, and that's not going to be an exact answer, so we're going to have to approximate. When we take the square root of 56, we get approximately, so I'm going to use my squiggle equal sign here, 7.5 feet. Since our ladder was in feet and our wall was in feet, that's going to be our approximate distance, is 7.5 feet. Okay? So hopefully you're starting to see how pictures are bringing together our Pythagorean theorem and helping us answer these questions. At any point, pause this and kind of recap and see how you're doing and see if you can put 2 and 2 together and try to figure these couple out. So for this one, it's all about drawing a picture again, but I want you to be careful because you got to make sure you know your north, south, east, and west. So my daughter in 2nd grade loves learning this, and so she said never eat soggy waffles. I'm sure there's a couple other ones you can think of. But if you're forgetting your different directions, that's there. So what I want you to do is I want you to start out by just drawing a dot on your notes, right? This is where you are right now. And it says first you drive 3 miles west. So west is this direction. So I'm going to drive 3 miles west and then put a 3 right there, okay? We then drive 5 miles south. Well, this is south, so 5 miles south. And finally, we drive 15 miles east. So quite a ways back this direction, 15 miles east. So there's a 15 right here. And the question then says, well, how far are you from where you started? So basically, what is this distance right here? How far are you now? This is where we are now. This is where we started. How far are we from there? And you should be like, well, that's not even a triangle. And you're right, it's not a triangle. But look at it for a quick second and ask yourself, how could we make it a triangle? And not just any triangle, a right triangle. So to make it a right triangle, think about where we could add a line that would create a right triangle. Hopefully, you're thinking right here. Because if we draw a vertical line straight down, this creates that right angle that we're looking for, and it creates a right triangle that we can actually identify the dimensions of. So our new right triangle is right here, okay? Well, let's think about it for a second. What's the length of this dotted line? Well, this dotted line going straight down here is the same as this straight down line right there. So it's got to be 5, right? And then if you make a mistake, the mistake is to just jump in with 15 and 5 and try to figure out the hypotenuse. That would be a mistake because this bottom side isn't actually 15, right? The whole thing was 15, right? But now we've actually cut it into 2 different sections. Our question is, well, what's this distance right here? That's the distance we're trying to figure out. Think about it for a second. How could we figure out what that distance is? The way you do is you say, well, that has to be 3 because up here was 3, so this is 3. And if you take the whole is 15 and that section is 3, then this section is only 12. Hopefully you're seeing that visually there, that 3 plus 12 gives me that total of 15. So my new right triangle, if you want to just draw a quick little sketch of it off to the side here, looks like this. The side right there is 5 and the bottom is 12. And we're still trying to figure out what that hypotenuse is. So now we can use the Pythagorean theorem. I'm going to do that over here. So 5 squared plus 12 squared equals, we don't know what it is, we'll call it x squared. So that's going to be 25 plus 144, and that gives me 169. So 169 equals x squared. You might have that one memorized. You should know that x equals 13. So this distance right here is 13 miles. We are 13 miles from where we began. All right? So I'm hoping as you practice that you're seeing more and more connections. I want you to try the next two by yourself, and then I'm going to go over them a little bit quicker, and hopefully you can see you'll be successful and you'll have a good understanding of what we're trying to do.